Okay, hello everyone. Let's get started with our groundwater flow and groundwater contamination flow. This is a slide that I'd like to share with you, and this viewer slide kind of explain the information that you need for this lab. I'm going to go ahead and start off with explaining hydraulic head. Basically, just remember the hydraulic head potential energy is for driving the water from high elevation to low elevation. Basically, hydraulic head is the level of the water table um, above the sea level, actually, or below the sea level, basically, in some cases. And the illustration that you see here at the bottom right corner, um, you see here that there is point H1 and point H2. So as you see here, H1 is higher in the water table than H2. And we knew that water table mimics the topography. Topography is kind of like higher in elevation and it's sloping here to the right the same way. You see that dash line, the blue dash line is sloping that direction. There's 2 points that you see here at P1 and P2, which basically shows that the weight of water over P1 literally is greater than the over P2. So basically, water flows. If I grab my pen right here and make an arrow here, the water basically moves this direction due to the um, fact that the water moves always from the higher to the lower elevation. And to understand this in reality on field, a piezometer is used to measure the hydraulic head. This is a piezometer right here. And this is a PVC pipe here. You see here, sticking out of the ground with a cap on that. So there is a flow meter device they put it in and basically lower it down until it peeps, and they figure out what the level of the water is in the well as water table. Now this water table is here, in fact, is hydraulic head. Now I'm going to go ahead and show you the next slide. Kind of like block diagrams. You don't have this in your book, so showing the zone of saturation, zone of aeration, or unsaturated zone, and you got the Earth's surface, the lake and river. Isn't it kind of like an area where water flows from high elevation to lower elevation toward the lake, right? So how do you imagine is below the Earth's surface? To understand this, I revealed that with this groundwater flow map or hydraulic um, gradient map. So basically showing, let me clean up this here, showing two sets of the line. One is the gray one with numbers on it, which is the water table contour lines, and the other one is the blue ones that we call it water flow lines. So I actually, in the last slide, I explained that here. So water table contour line with the numbers, and flow line, the arrow indicates direction of the flow, the blue one. So as you see here, flow is determined by measuring hydraulic head. And flow always move from higher elevation to the um, low hydraulic head. Basically 160, we have here 150, 140, 130. You see 10 feet is difference is between each of these lines as far as the inner water. Thus water table highs flow to water table lows. So eventually under the ground also flows toward the lake. So as you see here, if I dig a well here, you see here to the right, the well also shows that a cone of depression forms, and these numbers going down, and basically the flow line is also toward the area where the cone of depression is forming. So to put this all together, again, flow is determined by measuring hydraulic head. and it's always moved from high to low hydraulic head, and basically water table highs flow to water table lows. That's the part of the uh, facts from Darcy's law, which actually shows that permeability is also a factor. Some rocks have high permeability, some rocks have low permeability. That is going to be changing the direction of the flow, but there are formulas that you can consider here as hydraulic head, delta H, different in elevation of the water table, and then hydraulic gradient, which is that hydraulic head divided by the distance. And the steeper is the hydraulic gradient, is the faster flow, and less steep, of course, a slower flow. Um, there is an example here in next slide that I show you here, couple of arrows, and I'm going to clear here that the north part of the map is the top. So imagine the top is the north. There are two set of lines. One is with the numbers again. So I'm going to grab this here and make it clear. We got 10 here, we got 20 here, and we got 30. Say this is feet. So 10, 20, 30. Now, with what we said already, the higher hydraulic head is 30, and the next one is 20, then it's 30. So basically, this area is higher in elevation. On this side is higher elevation, the bottom right, than the opposite side. So this area right here is the higher elevation, and this area is lower elevation in hydraulic head. So I assume that the water flows this way, perpendicular always, and perpendicular to the contour line. So from A and B and C and D, I would choose which arrow that is showing the right direction of the water flow. Definitely, I would choose the C here, which is actually also from high to low and perpendicular. So imagine there is a septic tank, so that's naturally possible. For example, here in the middle of the map, there is a septic tank, and the water flows to the northwest direction, and the contamination basically move with it. So imagine the contamination moves this way. So underground, right? And there is a house here. Say here, there's a house here, and that house is going to be having a well. That well is going to be receiving that contamination. So imagine the well is right here in the backyard of that house. So if the direction of the flow is to the northwest, basically that house get contaminated because this contamination flows this way. So if I have a house here with this well here on this side, that is not going to be contaminated. Why? Because the flow direction is this way, and septic tank is here in the middle of the map. Okay, there are some related assignment on Canvas that you can check it out. So I'm going to go ahead and close this and show it to you here on this screen. Clean up my screen first and then quickly show you, and that's it for this short instruction. So I'm going to go ahead and show you the assignment in the groundwater section, and you scroll down here all the way to the bottom. You see here the two assignments for the groundwater. One is the groundwater flow direction lab. So this is something that's similar to what I said. This is the preview of that, and you see here similar material that I covered is showing here some kind of like question you need to answer. So you see here, these are all kind of like water table lines, and you got to understand which direction the water flows to understand which house get contaminated, etc. Okay, now that's one thing, and then we're gonna go ahead and see another one, which is actually similar topic, and basically is different kind of like version of that groundwater contamination flow. That I gave you a map of an area with the level of the water table in feet, and then you have the map here. There are some questions associated to that. Just to know that these blue lines are the lines as water table contour line, and then you got to understand which direction the water flows, always from higher number to the lower number. All right, that's the rule. Okay, if there is any question, let me know. Thank you.